This video is for the writing exponential growth and decay functions. So what we're going to do is we're going to write an exponential function from a table and then from a real-world problem. So let's start with a table. So for the given table, determine the a and b values and formulate a representative exponential equation. So the first thing that you need to do is identify the y-intercept and determine the a value. So when you have table, you always look for where x is 0, and that's going to be your a value. So my y-intercept is 0, 5, so my a value is 5. Now, to find your b value, you find the successive ratios of the y values, and what that means is you find the ratio between all the y values. So we would put 10 over 5, so you always go backwards. So 10 over 5 equals 2. So then I would do the next one, 20 over 10, and you keep them consecutive, so that's what the successive means. So 20 over 10 equals 2, and then the last one we would have would be 40 over 20, and that equals 2 as well. So that's my b value. So again, you take two rows, the highest, not even the highest one, I don't want to say that, the highest x value goes on top of your fraction. Then you simplify that fraction down. And then all you have to do is write your exponential function. So f of x equals, my a value is 5, my b value is 2, and then to the x power. So from a word problem, it's a little bit different because we have to create our own table. So presently the population of Juniper is 25,000 people. The population has been projected to grow at an average rate of 8% per year over the next 10 years. Determine a function to represent the problem situation. So the first thing we're going to do is create a table. So we know at year 0 there's 25,000 people. So to find the next year's totals, we can use this growth rate of 8%. And so how you use that percent, let me clear this out here. So we would take our starting amount and we would multiply it by that percent. So remember that 8% we can't use in percent form, but we can move the decimal 2 spots and make it a decimal that we can work with. So we would multiply it by that percentage converted to a decimal. The other thing you can do is anytime that you see a percent, 8%, you can type it in your calculator as a fraction. Put the percent over 100, and that's a really easy way to remember that. So when I do that, I get 2,000. Well, obviously, if we're growing, we're not going to go to 2,000. So what I have to do is I have to add that 2,000 back to the 25,000. So the next year there's going to be 27,000 people. And then I just do it again. So I can just hit times and then the 0.08. Add it. Now we got to add it to the line above, 27,000. So I get 29,160. And so again, when I'm hitting multiply like this, it's multiplying this 29,160 times my percent, and then I'm adding that 29,160 back to it. So 31,492.8, and I would multiply that times 8% and add 31,492.8, and so I get 34,000. Ooh, I got something different there. How to do that? 31492 times 0.08. Ah, that's what I did. If you see here, I multiplied it by, well, no, I did that right. So add 31,492.8. Nope, I was off. 34,012.16. Sorry, I miscalculated it the first time. So then we can do the exact same thing. We can find the y-intercept from our table. That's always our starting amount. So 0, 25,000. So our a value is the y-intercept of 25,000. Now to find the successive ratios, remember the highest x value goes on top, and you have to use successive in a row, 0, 1, 2, 3. So here, 1 over 0. Now what you need to do when we're working with these really big numbers is you need to type that fraction into your calculator. Alpha y 1 over 25,000. And all you have to do is just hit enter. And what that does is it simplifies it down. And actually what I'm going to do here, I'm going to change it into a fraction. Okay? 0.8. Or into a decimal, I'm sorry. Because this is the form that we need to write the equation. So for the next one, I would do 29,160 over 27,000. And the other thing that you can do is just divide it. 29,160 divided by 27,000. This will simplify it and convert it to a decimal. And every time you do this, the value should be the same. So now I'm going to go down to this last one, 31,492.8 over 29,160. 31,492.8. And I get 1.08. So my b value is 1.08. So my function, f of x, equals the a value, the b value, and then my exponent is x. Okay? So that's growth. Decay is identical. We do the exact same thing. All right, so for the given table, determine the a and b values and formulate a representative exponential equation. All right, so we find our y-intercept again, where x is 0. That's our y-intercept. So 0, 8, which means my a value is that 8. Then we find the successive ratios to find the b value. So we do 4 over 8. That simplifies to 1/2 or 0.5. So the next one we would do would be 2 over 4. That's also 1/2. And then we do 1 over 2, which is 1/2. And you can leave this in fraction form as well. It's okay. I know we converted it to a decimal in the other one, and that was just to kind of condense that number, make it easier to look at. So our function is going to be f of x equals the a value times the b value to the x power. All right, so for a real world problem, Mr. Green purchased a new combine for the farm for $120,000. That's going to be my a value. That's going to be my starting amount. So I can go ahead and fill that part in. So 120,000. Mr. Green determines it will depreciate 18% per year. Determine a function. So with depreciation or with an exponential decay problem, we would do this the same way, except, so we're going to multiply this times 0.18. But what we do this time is we take this amount, this 120,000, and we subtract, because it's decay, we're taking that amount off. So we would have 98,400. So then I would take that amount, multiply it by the 0.18, but this time subtract to get this number minus the depreciation, the amount that it's losing in value. And so what, I'm going to do one more of these, and then I'm just going to give you the rest. So 8688 minus 1453.84, I get 66,164.16. And so I'm just going to give you the rest of the values for this table. You can continue working them if you just want the practice. But we'd have 54,254.61. Actually, I'm just going to stop there because that's enough values for us to determine the b value. All right, so the b value. So we're going to take the higher x, and I know I'm saying x, but this is the higher x here. This is a y. And again, we can divide that. Top divided by bottom. And we get 0.82. So for the next one, we would do 8688 divided by 98,400. 8688 divided by 98,400. Same amount. And then do it one more time just to make sure. So now we have 66,164.16, and that would go over 8688. So 66,164.16. And as you do these, you'll see that you'll have to round off. If you use, that's why it's always best to start with your more exact numbers. As we would get further down this table, we would start rounding these digits off, which is going to knock this off if we don't use the exact form. So that's why it's best to use the y values that you didn't have to round off. So the b value is 0.82, and f of x equals our a value times our b value to the x power.